Hi, this is Rashekar, Assistant Professor in Triple Department. The main idea of making this video is to make the students understand how to simulate a string insulator and how to calculate the voltage across the each string insulator, and also to find the string efficiency. According to JNT lab, Power Systems and Simulation Lab, this is the second experiment, and in this experiment, the student is asked to find the voltage across each string insulator. Now, now, voltage distribution means how voltage is distributed across each string. Now, let V1 is the voltage across insulator 1, V2 is the voltage across insulator 2, and V3 is the voltage across insulator 3. I have taken 3 insulators, so 3 capacitances. We know that each insulator can be represented by a capacitance. Now, C1 is the capacitance from the insulator to this earth. Similarly, at B, at C. Now, this is the conductor. Now, the entire voltage which is passing through this conductor is divided into 3 voltages, that is V1, V2, V3. Some of the voltage is impressed across this insulator, and some of the voltage is impressed across this insulator, and some of the voltage of V is impressed across this insulator. Now, if you want to simulate this string insulators, now what I am doing is I am trying to convert this entire figure into equations. After converting this figure into equations, we are going to simulate using Skylab. So Skylab is a software which is available freely. You can download it, and I will show you the program which I have written to simulate this string insulators in the next slides. Now, if you take at point A, we can observe that I2 is coming towards point A and I1 is leaving point A and small I1 is leaving point A. Now, according to Kirchhoff current law, I2 is equal to I1 plus small I1. Now, current can be represented as voltage into resistance. Now, since I2 is responsible for by V2, V2 is producing I2. So, the relationship between V2 and I2 is V2 into omega C gives I2. So, I have written V2 into omega C is equal to V1 omega C, where V1 omega C is the current into this voltage into this capacitance or reactance of this insulator gives the current flowing into this insulator. Similarly, the current in this capacitance C1 can be written as V1 omega C1. Upon solving this equation, we got V2 is equal to V1 into 1 plus K. What is K? K is nothing but it is the ratio of C1 to C. This is C1 and this is C. Similarly, applying Kirchhoff current law at node B, again we can see I3 is being divided into capital I2 and small I2. So I3 is equal to I2 plus small I2, and similarly writing the equation of the current now and solving, you got V3 is equal to V1 into 1 plus 3K plus K square. That means you got V2 in terms of V1 and V3 in terms of V1. So in the previous slide we have taken only 3 insulators. Now let us write a program for 4 insulators. So I have extended the one more insulator, that is taking the current I4. So if you observe, I have developed an equation for V4 where V4 is equal to 1 plus 6K plus 5K square plus K cube into V1. See here, I4 is being divided into I3 and small I3, and small I3 is nothing but it is the combination of V1 plus V2 plus V3 into K omega C, and from this equation I have developed the equation for I4 is equal to I3 plus I3, and substituting the values of I3 and small I3, We got V4 is equal to I4 by omega c into 1 plus 6k plus 5k square plus k cube into V1. So we got three voltages V2, V3 and V4 for a 4-string insulator. Now I want to know what is V1 also. So here the total voltage V is equal to V1 plus V2 plus V3 plus V4. Now substituting the values of V2, V3 and V4 and solving, we got V is equal to V1 into k cube plus 6k square plus 10k plus 4, and V1 is equal to V by k cube plus 6k square plus 10k plus 4. So now the task is 80% completed. Only the next task is to write the program. To write the program, as I told you, we need some equations. So I got the equations V1, V2, V3 and V4. As you can see, V1 and all these V1, V2, V3, V4. See, V1 is in terms of V, and V2 is in terms of V1, and V3 is in terms of V1, and V4 is also in terms of V1. So if you know the value of V and K, you can calculate V1, V2, V3 and V4. The string efficiency formula is voltage across the string, that is entire voltage V divided by N into voltage across the disk near to the conductor. So which disk is near to the conductor? So the fourth disk is near to conductor. So we have to write the voltage V4. So string efficiency is nothing but V by N into V4 into 100. So let us take a problem. Find the voltage distribution across 4 string insulators and string efficiency connected to 100 kV line. So here the voltage V is 100 and K is 1 by 6. So let us write a program using the equations which I have described in the earlier slide. So find the voltage distribution across string insulators and find string efficiency. So the first line is clear, CLEAR semicolon, clears the entire variables which are used in previous programs. CLC clears the console and let K is equal to 1 by 6. That means the ratio I am defining with K. So I have taken the voltage 100 kV. So V1 is equal to 100 by K cube plus 6K square plus 10K plus 4. The first equation V1 we have derived in the earlier slide. I am writing in the equation form. Similarly, V2 is equal to V1 times 1 plus K. V3 is equal to V1 into 1 plus 3K plus K square. And V4 is equal to V1 into 1 plus 6K plus 5K square plus K cube. So all the four equations I have written as a program. Now printf will print the voltage V1. Here V1 is equal to percentage 0.2f. Percentage 0.2f will take the variable value which is described here. So here I am taking V1. So V1 value is placed in terms of percentage 0.2f. So V1 is calculated with the in the above second line. So that value will be placed here. Similarly V2, V3 and V4. So string efficiency is equal to V by 4 into V4 because I am taking 4 string insulators and V4 is the voltage across nearest to the fourth string and into 100 gives in terms of percentage. So the last line will print the string efficiency. This is the program which will calculate the voltage across each string and string efficiency of the in the given problem. Hi, this is the Skylab environment where you can type the programs or you can write programs and you can simulate here. So this is a freeware where you can uh, develop the programs. Suppose I have written, already we have seen the program, so I have written the program. How to write this program is just click this editor, so it will open a new editor, and here I have typed the program, the entire program which I have shown earlier. So clear CLC defining the value k, v1, v2 and v3 and v4, the variables, printf command, and finding the string efficiency and printf string efficiency. Now if I run this program, then in the SCI lab console you can see the v1, v2, v3 and v4 values and string efficiency. So for that value of k, the string efficiency is 68. Now if I increase or decrease or change the value of k, what will happen? Suppose the k is 1 by 2. If the value of k is 1 by 2, and if I run, it will ask for save and execute. So again see, v1 is v2, v3, v4 are changed, and string efficiency now is 49%. Now if I still change this, I will change to k is equal to 1 by 8, and if I want to run this program, let us see what will happen to the string efficiency. It is 73. Like that, this program we can find the voltage across the 4 strings insulators and string efficiency if by defining the value of k.